I love fossil fuels. I'm supposed to be presenting a clean tech company, and yet I'm up here declaring my love for the dirtiest form of energy. Fossil fuels are abundant, they're dependable, and my favorite fossil fuel, petroleum, can be transformed into everything from transportation fuels to plastics to household products. So why am I at Ocean Exchange today? Well, it's because I know my dear fossil fuels are fatally flawed, and I'll save you all the recap of the environmental and geopolitical challenges they represent. So what are we to do? Well, what if I told you that you could get the benefits of fossil fuels without the environmental cost? What if, further, I told you that I could generate the same plastics and liquid fuels and products from the very waste products that fossil fuels generate? I'm Nicholas Flanders, and along with my two co-founders from Stanford University, I represent Opus 12. We're building a reactor that can transform CO2, water, and electricity into valuable fuels and chemicals. And they're cost competitive with conventional products. Our technology can bolt onto any existing source of CO2. Our first market is existing fuel producers. So that's oil refineries, corn ethanol plants, and natural gas fields, who collectively emit 100 million tons of pure CO2 each year in the US alone. Without our technology, they're throwing away $40 billion in value and exposing themselves to significant regulatory risk. We've validated our technology with major players from across the industry, from Exxon to Chevron to Valero, and the largest ethanol producers in the West. Just 3 years ago, I couldn't have been presenting this solution to you. See, our technology builds upon very recent advances in nanotechnology, material science, and 3D printing. And our founding team is at the cutting edge of those fields. We also know how to bring a product to market. We have experience in bringing industrial technologies to scale, and I have previous startup experience with great success. Our technology represents a tremendous opportunity. A $40 billion market in the US, a massive reduction in greenhouse gas emissions, and a new domestic fuel supply. At Opus 12, we're transforming the way the industry thinks about CO2, and I think I found a way to get past my love for fossil fuels. Thank you.
All right. And all that in 2.5 minutes. All right, who wants to go first? Alan, Mark.
This is something that obviously people have been trying to do in various forms, in a lot of ways. What took you over that hurdle? What was the discovery that made this possible?
So we've actually found a way to integrate this technology into an existing reactor design. So that greatly mitigates our scale-up risk. So all of our core innovations is actually around the catalyst layer and the way its composition, as well as the nanoparticles themselves.
So I read through everything. I think it's just a tremendously exciting idea.
Thank you.
And I think it's a good idea to start with the ethanol, although, what is your, if to the extent you're willing to share, like what is your variable cost to create a gallon of ethanol between electricity, the CO2, the catalyst? How does that break down?
Sure. So what we've done is we've gone out to a couple customers and just gotten their input costs, so what they pay for electricity, if they're selling their CO2, for example, what they're paying for it. And so some of our corn ethanol plant customers, for example, we could make ethanol, basically take their CO2, turn it into more ethanol for about $1.30 a gallon. The 5-year average price of ethanol has been about $2.50, so it represents a significant margin. We've also talked with some utilities in Texas, for example, just to look at kind of what the best possible scenario would be. Our reactor has a relatively low capital cost, which means that you could run it just at night when electricity prices are cheapest. In that case, you could get as low as 87 cents a gallon, even with the 1/3 capacity factor.
Jeff.
Yeah, can you talk a little more about the CapEx associated with this, just because anytime there's a reactor, anytime there's something like this, that's always the barrier.
Yeah.
And it's always the barrier to get it funded, and it's always the barrier to see how you've been able to prove the cost economics you're talking about as being as advantageous as you'd like them to be.
Yeah, the way we know they're real is because we've actually partnered with an existing systems provider who actually makes the type of reactor that we're integrating into, so we're using their capital costs. So it really is just a question of integrating this new this cathode catalyst layer into their reactor and then scaling it up from there. So
that one particular piece is the core of the innovation that drives all of this to work?
Yeah, it's the new layer. It's also the nanoparticles themselves, and we've also developed some new materials actually for the interior of the reactor.
Great. Good. Kelly.
What other products can you make besides ethanol?
Yeah, we've actually demonstrated 16 different products. The other one that we would go to after ethanol is ethylene, so it could be a basis for plastics. For 1 ton of ethylene, you'd actually sequester 3 tons of CO2. So we see that as a big market. We can also make 3 carbon products like propanol, as well as kind of other solvents and chemicals. So the top 8 of those 16 is a $400 billion market globally.
Anybody else? Mark.
So the places other than the North Sea or wherever else it's been economical to capture, I assume the CO2 is just vented. Is there any major challenge for tapping into that, or is it kind of there for the processing once you have the ability?
Yeah, especially,
CO2 stream.
so part of the reason that we're targeting those existing fuel producers first is because in various parts of their processes, whether at an oil refinery or corn ethanol plant or at a natural gas field, they're actually already separating CO2 that's more than 90% concentrated, so we can actually just flow it right into our reactor without any problems. Ocean Exchange, thank you so much for the opportunity. I'd really appreciate your vote. Please come find me after if you want to ask any more questions about technology. Thank you.
Stanford University, Nicholas Flanders.